Hello everybody and welcome back to the channel. The Slammed X or Zerro3 is done. The build is complete, many flights in hand, and I've crashed it as I do just about everything many times. I love to fly, but rarely does a flight session or a single flight end in a nice smooth landing. It usually comes tumbling in, or I gotta do the walk of shame across the yard. I'm very pleased, of course. This isn't about me because I'm going to have my own opinion on this and I'm going to be pretty biased. I know that more than a few of you have mentioned these props and how inefficient they are. It's not that I don't care, it's that I've got a bunch of these props. I ordered them maybe a year ago, and so I use them. I did get a recommendation from one of you, and I did buy some other props. They seem to be back ordered, most of the sources that I purchased from, so I'm going to have to wait patiently for those. A couple of caveats before we get into this. The motor protection that I mentioned in the last video, I don't know how worried I am about that anymore, because I smacked this thing head on into a tree more than once, and the only damage I've got is this little, I think it's chipped. The back end of this prop is chipped, but that's really the only damage I've seen so far. And everything is held together extremely well. It seems to be very durable. None of the weak points that I point out in the bottom is anything of concern, at least so far. You know, I'm not going full throttle because I'm not flying in huge spaces, but I'm flying like I do, and I've hit the swing set in more than one tree and the ground a whole bunch of times. And the worst thing that happened, I did go about 70% throttle straight into the ground. I was attempting to do some acro stuff, and I smashed into the ground, and that motor dead. So I swapped it out for another one I happened to have, thankfully, and got back up in the ring. I think it was this one, actually. Nikita and I have been over several things. We've had a few email exchanges since the first build, and I really appreciate all the feedback that you've given us. I really appreciate that a lot. As I stated in that video, I don't claim to be an expert in how to design quads. I just had an interest in flying something I hadn't seen before, and I wanted to try it out. Did end up doing something different with the VTX. There was more than a couple of comments also about how the parts may have been poorly planned. And, you know, when you get something that's new, that's no one else has done, you're kind of going to be at a disadvantage because you don't know exactly what will fit. This isn't designed to fit everything. Our VTXs haven't really gotten all that much smaller over the course of the last year. The HawkEye is one of the smaller ones. I think it comes in at 23 millimeters by 20 millimeters, but it's got this long pigtail, and then the right angle adapter that's in there that can kind of get in the way a little bit, because you can see we've got a, well, I can't hardly show you that. There's a little bit of a gap, probably 3 millimeter gap between the coil of the pigtail and the actual VTX. And that actually made me think of something. Why haven't we seen a really small VTX? I know that Furious FPV has got the, what is it, the Innovia or Innova, something like that, that you can integrate right into the Piko BLX. That's also got an OSD in it. But if we take a look at these microcams, this is the TX-02, which is a 200 milliwatt camera and VTX all in one. This sort of thing would be great if somebody would just produce this with just the back half and a UFL connection on the back, or, you know, even if they put an SMA connector on the back, that still would really help the micro builders and being able to fit something like this on here. You can see that, well, if I get this turned around, that would fit clear up to the rear posts, and we wouldn't have any problems with prop clearance. That would really help. So hopefully we'll see that soon. I'm actually, now that I'm in this build so, well, while I was in this build so deep, it occurred to me one night when I went to bed, I was like, why don't we have something this small in a VTX? We know it can be done. We got it right here. I know that we can separate these and we can use them like you might with a normal VTX. My preference would be for something that is going to be flying at the speeds that these can, that it's a little bit more robust. So maybe some heat dissipation, some shielding like we see on typicals, just smaller. Just reduce the size, put it on a PCB that makes it a little bit more durable. I think that would be something that a lot of us would buy. And if you look on Facebook, there's the, what's it called, the micro brushless or custom micro brushless builders. There's also the same group, but for brushed. And I'm sure there's other groups I'm unaware of and other people that I'm unaware of that builds a lot of micros as well. It just surprises me that we haven't seen something extraordinarily small in the VTX. And I'm also wondering how long it's going to be before we start to see cameras that come out that have the wide dynamic range that we see in these CCD cameras. I know that Quattro Volant, who makes the Carbon Q, which I built, he has found a source for a micro cam, just similar to what we see with this, that actually uses, I think it's HDR, and it handles light quite a bit better. He demoed that. I think it might have been on one of the Facebook groups, but you can buy that from his, I believe you can buy it from his web shop at quattrovolant.com. I think that camera is relatively expensive still. I think it was 30 or 40 bucks. So it seems like we're inching there, and maybe the micro group is starting to gain a little traction. We're seeing a lot of companies start to jump into the brushed micro arena. I've actually got a Tiny QX here. We'll get to that soon. But it works well. It flies great. The durability, I don't really have any concerns about that. And what we'll do is we'll jump right to some flight footage, and then for those of you that are interested in the build video, that will follow up. One pitfall that I did have, and I'm not quite certain how it occurred, if you see that little bit of yellow there, somehow I mashed up the signal wire off of this ESC. I don't know if it's just the number of times I put the camera assembly in and it just kept fraying the edges off, and then finally one time it just wouldn't spin up the motor. That was something that I don't think is a design problem. It's a builder problem. I should have been more careful. I do also use a smaller strap than what you'll see in the video, the Furious FPV battery strap that's rubberized on the inside. That was just too big. It was actually just too long. You can fit it in there, but it was so long I was going to have to chop it down. I really didn't want to chop down a rubberized battery strap that's too nice. So I had this in the bin. I chopped off the little end. It has a little end that loops around here. I chopped that off because it was annoying. And we're looking at changing this hole to where you can put some, anti-slip pad or Velcro or anything else on there, and it'll stick a little bit better. Mine is sticking okay, but I do find it a little bit fussy to get the battery to stick to that, just because the amount of space that we have that's firm back here isn't very good. Nikita is also looking to add a couple little notches back here, so you can actually take your JST connector and mount it to the board right at the back, so you can take your battery and stick it in there just about like it is on the Carbon Q. There really isn't anything that I can think of that we can do for a place to mount the buzzer. Another area we haven't seen much development in microsizing. The buzzers are pretty much all about the same size. I had a Lantean buzzer that was supposed to be super small, but it was only minorly smaller than this, and it wasn't super loud. It said it was super loud. So let's jump to some flight footage, and then we'll look at the build. The build does include the full configuration through Clean Flight. I get a lot of people asking about how do you set up this, and how do you do stick or switch arming, and how do you do the calibration. And oftentimes I just point them to videos that maybe UAV Futures have done, or Albert Kim, or Josh Bardwell has done. Those guys have a lot of great videos, and if you're not watching their videos, I encourage you to do that, because they do a lot of stuff, and I try not to replicate what other people do too much. There may be some overlap, but I try to keep that pretty light, because I watch their videos too, and I really like what they do as well. So let's jump to the flight footage. I'm sure there'll be many crashes you all enjoy, and then we'll start the build video. We're going to start this build a little bit different. Rather than having all the parts laid out that we're going to be putting together, we'll discuss the parts if we need to as we're building it together. We're going to start with the motors and the ESCs. First thing we're going to do is do a dry fit. I'm going to use the wrap technique on these. And because this is going to be motor 3, motor 3, it needs to spin this way, which just because it says that on the top of the motor doesn't mean it will do that. Typically these 1306 motors actually all rotate clockwise. It's just the threads that are reversed. And with that, we're going to cross 2 of the wires when we solder this on to make sure that it does rotate counterclockwise. If you want to go straight through, you can do that. And Blheli, you can change the motor direction easily through there. And we can see that wrapping isn't going to quite work. We don't quite have enough length. And even if we cut a notch in that heat shrink, it's not going to quite reach. So we're going to just lay the motors down and solder them that way. But the first step, and I think I'm going to shorten these just a little bit. Let me get my cutters out here. And cut them approximately there. And then I'll strip them with my fingernails. Do what I can to twist them with my digits. Get our good old blue tack out. We're still zoomed out quite a bit, but it should be fine. There we go. There's one motor. Let's do the corresponding ESC. You'll note that because I'm right-handed, I'm always bringing the heat with my right hand and bringing my solder down with my left. Just how it works out for me. Maybe you're a little bit ambidextrous and you can do it another way. Whatever works for you. And this one is motor 3. Let me strip down our blue tack here just a touch. We'll make 2 pieces. One for our ESC. One for our motor. Actually, because I'm going to loop, I'm going to stack them. There we go, that looks better. I'll rotate this a bit. Now this is where I'm going to cross. I'm going to take the middle wire. I'm going to go to the outside, so I'm going to bring the outside wire to the end because that's motor 3. So motor 3 and motor 2, we want to have cross 2 wires. Or again, you can switch them in Blheli. Let me do some finger adjustment here. Did everybody see Game 7 of the World Series the other day? As an old baseball guy in a previous life, I used to play ball, and that was a really good game. I was really pleased that it was so competitive and had all the drama and the back and forth, and very competitive. There were some questionable managerial moves, but you know, that's part of the game. We're humans. We do what we think's best, and sometimes it's right and sometimes it's wrong. Let things cool for just a second. Do a little pull test on these. Looks good. Okay, so cross them over like this for motors 3 and 2, and then for motors 1 and 4, you can just go straight through. So do that for all 4. When we come back, I'll have these all mounted up, and we'll start to solder to our Piko BLX. We've got our motors and our ESCs secured. A couple things to look at here. As you can see, my flight controller doesn't quite want to sit down flush because I've got the battery strap in there. And I'm going to try to keep my hands out of the way, but I've just gotten this camera lined up, so I kind of have to keep my finger on it here, and we've got this hornet's nest of wires. So this is a rubberized battery strap, so the ends are pretty stiff because there's double layer there. And you can see how the strap is kind of up on the standoff there. And that's due to the strap cutout locations. We might want to change that in future iterations, but you can get the flight controller down. You just got to work this down here like so, and then you apply pressure, and then you put your nylon lock nuts on top. We also take a look here at the front before we go any further, and you can see that we're going to have to route the wires out around the standoff. So that's not especially clean. You could probably stack them and go between here, and we might do that. My concern with doing that is these carbon fiber mounts for the camera aren't necessarily easy to get down in there, and if you have wire creating pressure, it might be more cumbersome. But we probably won't be taking this camera out too much, because hopefully we've built the frame in such a way that the camera won't be taking impact, so we have to get to it. And we can access the OSD ports from the bottom. So I'm just trying to think of a really good way of doing this and keeping it all clean, because we've got to come in here to the front, and we've got a gap in there, and normally our camera is probably going to be pointed up, and that board will be down further too as well. Because if we run it in here and then we end up having to loop it back around, we might not have enough slack in our wires to change that. So that's my concern, kind of talking through this a little bit. Now if we go underneath the camera, that's going to probably create some difficulties. Yeah, that gap down there is way too small. We're not going to be able to go underneath the camera either. So we either have to go out around, or we have to stack our lines over the top here. My other concern is if I do it this way, I pretty much have to leave the camera in place to make sure that I have the wires run in such a way that I can get the camera back in there. I want it to be clean. I think I'm going to do that. When I do this, I'm just going to make sure that when I do my dry fitting, I press these wires over here and make sure that they're touching that post, so I make sure that I have enough slack to get those out of the way. Yeah, that's what I'm going to do. Okay, so let's take this off. Oh, and with your flight controller, plug it in. Make sure you update it to the version of firmware that you want it running before you solder it on and get it all mounted up, because maybe it doesn't work. And that's really disheartening when you get everything all set up and then you find out your flight controller won't boot up. Here's a better look at what we've got with these standoffs here. This cable is just a little bit too wide. It's 15 millimeters, I believe. So we would need probably something 12 or 10 that would actually just run cleanly through here. And I actually ordered some of those small battery straps from my RC Mart, the RCX ones. But stuff takes even longer to come from there. And that order's hung up for some reason. I don't know. I contacted customer support to see what the story was. It hasn't even posted yet, picked nothing. It just still processing, just like the day I ordered. Let's tin up our pads. Oh, and this showed up today. This is the SQ8. It says Full HD Mini DV 1080p. If you want to see a video on that, leave a comment below. Otherwise, well, if you leave a comment below and it turns out this is just junk, I think this was only like 10 bucks or less. It's actually kind of heavy. It's got a really solid metal case on it. I'm always looking for an option of HD video recording on top of our micros. I've got those 808s, but it doesn't record reliably, and that's a pain to me. So I picked up one of these to see if it would do any better. So if you want to see a video on this, let me know. If it's complete junk, I'm not going to post a video just for filler. Tin these up, same way we do just about all the other tinning. Put our heat, bring some solder, get a nice little blob on there. These are all our ESC pads and signal. Make Make sure your soldering iron is good and hot. This board is tiny and these pads are close together, so don't go overboard. If you're following along, I'd encourage you to pull up the blown out version of the product on the FuriousFPV.com website so that you can see all the different labels. I'm actually looking at that up on my computer screen because standing back from the camera, I can't quite make them out most of the time, especially with my vision not being as good as it once was. And I think I'm going to do my battery leads from the bottom, because that will help keep all this a little bit cleaner, and I've already actually got a couple of pieces. So if we do those from the bottom, then I can do the VTX and the camera off of here. I don't know if this will fit on or not, but this is the Piggy OSD from Furious FPV. It's designed to go on the back of our cameras. You can see the design is laid out, and they actually don't show you using the screws to mount this. On their website, they actually show you just put a little piece of foam tape right on the back, and then you stick it on here, and then you wire these in, and this is all upside down. You wire from your camera port up here into those three. You've got a cam, 5 volt and ground. This side is for the FTDI, which I hope not to have to use, hoping to just use pass-through. And we've got our TX and RX that would go to our board down there as well. So I'm not sure if this is going to fit, especially with that connector. I think that connector is made to use with the Combini, the larger flight controller that they have. But we'll see. Maybe we'll use this when we get to it, if it fits. I'm going to go ahead and strip and tin up these wires. And the negative is our square and the positive is our circle, right? Yeah, according to that schematic. So if I can get this to go up through there, which it's not natively, so maybe I have to squinch it together. There we go. Okay, now does the red one fit up through there? Yeah, there we go. Gonna have to rotate that to hit the other side, I think. Probably good enough the way it is, but okay. So we should have plenty of clearance for those to come out back. I didn't get that one pushed up quite as much as I would have liked. It should be fine though. Okay, I've got the flight controller mounted there solidly. It shouldn't be going anywhere. I got my battery strap where I want it. So now we have to start dealing with this hornet's nest of wires. Let's go ahead and jump right in and start with the front. Typically I just wrap these around, try to get them out of the way as best we can. So we just have our subjects. I'm going to turn it around this way so I can use my left hand. And middle pads, again, these are our positives, these out here are our grounds, and in between the two are our signals. And I'm going to go ahead and use the ground, and I'm just going to use the common ground. So ground from the ESC, this wire, as well as the black wire from our twisted pair, will be going to the same pad. So we need to get a dry fit. Let's do this side first. I guess I could always kind of loop it around and come in from the back side. Maybe that was something I didn't think about earlier. That gives me the possibility of coming back and making correction. Do our same with the black wire. Fingertip strip. That one's not wanting to come clean, so whoops, bumped the camera with my head. We'll tin those free in the air. I'm going to go red wire first on the bottom because it's the furthest. I'm going to turn this a bit, move this wire out of the way. I'm going to grab it and bend that down a little bit. Try to sneak my head around the camera here. Make sure I get the right pad. I don't have my needle nose on the wire right. I've got too much hanging up there. That's one. Let's do the black one next. If my dry fitting was correct, I shouldn't be getting a problem with this. We don't have to worry about another standoff going on top, so we should be good there. Now we need to do a dry fitting for our signal wire. This actually I need to straighten out a bit. So if you're doing this, give yourself a bit of slack, a little bit of room for error. So I'm going to cut the group right there. So let's strip and tin. These are not silicone, so I have to use my little cutters here. Because these are plastic coated or nylon, we need to be a little bit quicker. We're going to get some burn back, or at least try to be quicker. We still want to get good solid flow through there. This is the one you got to be the most careful, right in between those pads. Got quite a bit of slack there. Should have probably cut those a bit shorter. Now we do the black wire and hope that our ground wire from the ESC does not come loose when we do this. I think I got it. Not pretty, but it's on there. Okay, so that's one. Now just do the same to the other three. You can see I've got everything wired together. And this is the step, especially when you're building micros, especially when you're using really small boards, that if you have access to a magnifying glass, I highly suggest you get it and start to look down between all these little gaps and make sure that none of your solder bridged any of those pads. That's the best thing you can do, because once you plug in that battery, it all might be over. You might get lucky and a wire just pop off, but it's best to inspect beforehand and be safe. A couple of tips if you do this. I ended up removing the rear standoffs in order to get these soldered on, and I also removed the rear standoff in order to do this side, and that was because when I tried to bring my needle nose in from this side, the standoffs were always kind of in my way. So I removed those in order to get the front, and then it came in handy in the back. You can see we've got a little bit of a wiring mess, but you know, it's kind of the nature of micros. It's hard to make them especially clean. Darun, I've seen on RC groups, he has a special skill for making really clean builds with micros. I wish he would post some videos of how he goes about doing it, his methodology, and kind of what he's thinking. But look on RC groups. It might be Dan Q as well, might have some really clean builds. So mine aren't as good as theirs, but they do work. Now for the Piggy OSD, I'm going to need access to UART1 and or UART. So UART2 or UART1. I'm going to need access to these UARTs that are labeled over here, and so I had to give myself a little breathing room because I don't want to bring my solder iron in and then end up burning one of these wires. So that's why you kind of see things coiled up like they are. But we're getting pretty close. Really, the hard work of getting all these solder pads with our ESCs done is kind of the hardest part in my opinion. Now I do need to check to make sure our camera, I did a dry fit earlier after I got the first one done, and I need to do another dry fit. And I'm sure I'll have to cut away. The standoffs for the camera mount, the short part goes down here because remember the camera goes down into this recess. So make sure you have those down. Another way to look at it is the curved part forward. So I'm going to fuss with this a bit because it is fussy to get down in there. Okay, I believe I have it now. And I kind of have to keep my fingers, you can see they're sunk down in there a little bit, and from the top, well, this one isn't quite down all the way. There we go. Now I've got it down all the way. And you can see this is the lowest amount of camera tilt you're going to get, and maybe even up a little bit more by the time we get that VTX wire plugged in there. So this obviously would be better if we bought a camera that was top mounted, but I guess I like to do things the hard way, so I'm going to do it the hard way because this is the camera that I got. I have another RunCam, but it's the same way. It's actually the RunCam Owl. And if we look here, we're still going to be able to get some pretty extreme up tilt. Now with the Piggy OSD, that's going to decrease a little bit, but I left myself some slack with this black wire right here so that I could possibly get it up and over this mount here, so that would help to increase that. And here's another look at it from back here. You can see where we're hitting that wire. But we're in pretty good shape. I'm pretty pleased with where we are right now. I think the next part I need to look at doing is the VTX. And that's going to be relatively simple. I scavenged this VTX. It's a HawkEye. It's pretty nice. And I scavenged this one because it gives me some flexibility, and unless I know exactly what's going to fit in here, this flexibility is going to be pretty important. You could probably use a standard VTX with a right angle adapter and it probably work just fine. There might even be other VTXs that are smaller than this out there, and that's something I think would be very interesting if Furious or one of the other companies that's doing a really good job of creating micro parts. How come our VTXs really aren't shrinking all that much? Yeah, they've shrunk. They used to be giant, and they've gotten down to this, but in the last year, we really haven't seen them get smaller than this. I'm wondering why that is. Maybe it's just heat dissipation, or some radio or something just hasn't gotten smaller. But so changing our channels is obviously going to be a pretty good challenge with this, depending upon, let's see if we mount it this way. We might be able to access those pins to change channels. But that's the next part. A few things have changed since the last cut. And what those things are is I've put in the RunCam Owl, because to my knowledge that has one of the bigger or biggest lenses that we'll see on CCD cams. And I wanted to make sure that it had clearance. So if we put and this has still got the lens cover on it too, you can see It comes pretty close, I would say 3 millimeters. And oddly enough, it's closer on this side. I have a feeling I don't quite have it on perfectly. But everything spins fine. Extreme camera angle. And this camera has top-mounted, I'm trying to hold it together. It has top-mounted ports. So that will give us the ability to go down just about as far as we can. Not that I would ever fly like that. That would be, let's see, so you'd be flying about like that. Let's see if I can hold that to the camera right. That looks like the camera would be about level. Plus, this also gives me the ability to try out the RunCam Owl because I haven't had a chance to try it yet. I do think for right now, I'm not going to put the Piggy OSD from Furious FPV on there. This is take a quick look at the board. It's really plug and play, I think, for the Combini, which is also from Furious. You just plug this cable in here. If I get this lined up just right. And then you plug this into the special port on the Combini. In our case, we'll have a little bit more to do. Well, there's also some soldering. I think it's these ports you put into your cam. In our case, we're going to have more work to do. We won't be using this port at all. But the reason why I'm not going to put it on this build is, one, I just want to get this thing up and flying, and I want to test it out. And two, it would make it a lot easier to break out a video for anybody who wants to know how to use this with the Piko BLX. So I can cut that out. I'll do this, in the coming week or so, and we'll take a closer look at that in a separate video. But for now, let's just continue on with our build. So really starting to get down to the final stages. We need to connect our camera to our VTX and power. And this is what we're going to use. I'm actually not going to use, let's see, this is for the VTX. I'm not going to use the power that comes off of the VTX to power the camera. I don't really see any use in that. And it kind of ties the two together. Doesn't really tie them together because we can just always unplug these. I think now that I got this with the ports on top, I just might use these. Put it in here. That'll be the shortest run in history, probably. Look at that VTX. Look how close that is. But we'll create some slack in there. And I'm using a Spectrum satellite. If you're a Taranis user, you're going to want to look for something that's about the same size as this. Otherwise, it's just not going to fit with all our wires having to loop around. We've got more room in the back because we were able to come back here. And the Piko BLX has a Spectrum port right over here. But if you're using something other than this, then you'll have to wire up to the UARTs, of course, to get your receiver working. And I don't think, now that we've done a little dry fit, you're going to get a bigger receiver in there at all. There's just not enough room for it. Here we go. Found our first fatal flaw. I should have checked this in the previous video that I just posted tonight. SMA hole's not big enough. It's not going to go through there. So I'm going to have to drill that out in order to make that work. You can see the top portion, but the threads just don't get through there. So we need another mil or two there. So we'll have to work around that, but let's continue forward. So we've got our cables out here. They're really nice silicone wires. If you're not familiar with the RunCams, they all come with these really nice silicone wires. Really easy to work with. You can really twist and turn them around. And the HawkEyes, they come with it as well. It's just a smaller gauge. And it's a 3-pin connector, obviously. Our OSD connector goes over there. They include that in the box. And these RunCams include 2 back plates. One back plate that has the second camera mounting to make sure that it holds the angle, and the other back plate is flat like this one. So we're just going to get a little bit of a dry fit. There really isn't much of a dry fit to have here, is there? Am I doing that upside down? Yes, I am. So really all I'm primarily concerned about is making sure that these wires, there's not so much slack that it gets out into our props. So we could really cut them anywhere in here. We'll go ahead and do that. Where are my cutters going? There they are. Save these wires. These are the rarity. They're the exception, not the rule. So always keep a hold of these. These are great. And I'm going to trim these about the same length, really. Now I'm going to unplug all this stuff. This is already really short, so we'll just solder this directly to the board by the time we get everything crammed in there. The pressure alone should keep it from coming out. So this is pretty straightforward. We're just going to tin and solder these together, use a little heat shrink in there. So something I've been meaning to talk about during this video was how many Chicago residences are out there. I know there's got to be a few of you, and with the Cubbies winning the World Series, I heard that there were as many as 5 million people that showed up for that parade. Were you there? I would be interested in hearing any tales you might have about that experience. Kansas City is the closest to me that has recently won the World Series. Needless to say, I was not in attendance of their parade. But I follow baseball relatively closely, being an old baseball player myself. So those things are always of interest to me. And my kids are lucky enough to where they got to be alive during the time when the Cubs won the World Series. Now I need to show them, what was it, Back to the Future 3? Where they had predicted the Cubs would win the World Series? I'm pretty sure it was. I could be way off though. I've been known to be wrong. I believe Furious FPV also has. They've been really, they've been doing a lot in the micro arena. I think I need to go through their parts and see what else I might be able to make of use. I'm wondering if they're working on a board like the Piko with an OSD built in. Wouldn't that be something? Seems like it would be somewhat logical for them to be working on something like that. This is the longer side, so I'm going to take it off. I'll get some matching heat shrink. I bought heat shrink packages off of eBay. I'm not for sure if there's any heat shrink out there that is, I've got to have a really tiny piece that is more flexible than others. And I save all the little bits. Well, I can't get that one out. There we go. We're not going to need much. Put this back in my little bag. But the as I make a lot of noise here, the heat shrink package I think was like $7 from eBay, and of course it takes a real long time to get here, but we either have to pay a lot more or we just have to wait for it to get to us. I need to get these up in the air a little bit more. I'm going to take this off. Oh, I lost my heat shrink. If any of this looks hard, I'm probably making it look harder than it really is. Because filming these things is like looking at everything through binoculars. Alright, I think I got it. Let's do a little pull test, especially on that one. Yeah, that's good. Put our heat shrink into place. You can see we've got way more length than we're actually going to need, but what we'll end up doing is something like this. You just loop it around. The other part of this equation is our receiver. You can see I've added some hot glue to the top, and I've also shortened the lead pretty dramatically. This comes with leads that are, I don't know, 8-9 inches long. We don't need all that, that's for sure. So that goes right in our little spectrum port down here. I'm going to do it this way, so I'm just going to kind of fold things. I need to be able to gain access to that USB port down there still, so I don't want this really in the way that way. You can make this smaller by removing the connector and just direct soldering, but I didn't really think that was necessary. The amount of space you save is, and you might find it useful for some particular builds, but I haven't found one that I had to do that yet. So that will go there, and then our VTX will go in that space above it. We should be fine. I will put a little piece of the foam tape that comes with the lemon on the bottom, and I'll put some electrical tape on the top. But I also wanted to put in a buzzer. So you can see I've got a buzzer prepped here, and they mark the plus side, which is generally the longer lead that comes off is generally the voltage side. And I put a little bit of heat shrink on there. Our buzzer pads in the board are this one and this one. This is our positive, this is our negative, or our ground. So I need to tin those up, and then I'll have to shorten these. I don't know where I'm going to set that though. The buzzer's kind of big. Can I wedge it between here? I guess I could stick it out the back. Okay, I do think I'm going to put the buzzer, and I'm going to put it out the tail because it's about the only place I can go with it. And then I can always use the back of my Spectrum to put a little bit of hot glue or foam tape to kind of secure this in place. And we'll have plenty of clearance with our props still. And I don't think I'm going to trim those wires any shorter either. So let's tin them up and get them in place. My hand's blocking your view, I'm sure. I'm having a hard time getting that one. I had it once, but I didn't like the location. That's better. That went down through the hole. Alright, I think it's time I cut some foam tape here. Let me get my scissors. I always pull off this side first, or not always, but when I remember, this side is fussy. The white side comes right off. Oftentimes I have to kind of pinch in a side and grab a hold of it with my cutters. Ah, got it. That will keep that from shorting on the board. I'm going to go ahead and get some electrical tape. The only part about doing this is that you can't see the LED light on there, so you know if you're bound or not. Again, choices we have to make in these micros. We don't have room to do everything that we might want to do. And then the buzzer back through here. I think what I'm going to do right now is I'm going to step away for a second, and I'm going to put on my JST connectors. That's going to be a bit fussy because they're big, they're short, thick wires that JSTs don't necessarily like all that much, but I know they work because I've done it several times before. And then we'll come back and finish up with the Vtx. You can see I've got my JST connector on there, and that was a bit of a job. I should have done that before I soldered that thing on. But we got her on there. It should be fine. But I did forget that we need power here. So in many cases where they have internal filtering, and you'll need to check your manufacturer's spec sheet on your Vtx, you can go directly off of the battery leads, which in our case is down here. The Piko BLX features LC filtering over here, as well as I think the whole board is actually LC filtered, because there's been a number of other people that talked about this. And on my first build I used a 5-volt regulator to power a Vtx on the Carbon Q, and many people then came back and said, why'd you do that? And I said, well, at the time, Piko BLX was very, very new, and we just didn't know for sure. So I added that. But in this case, we need to get some power to our Vtx, so I've got this ready to tin up here. Got that. Now let's tin up our board. I'm going to end up probably getting this right in the way. Let me see if I can create an angle where my fingers aren't so... Oh, my nose. My iron has got a glob on it. Let's clean that off. There we go. A bit more of that. I use real fine solder because it's easier to work with and stays out of the way, especially on those micro builds. If you're soldering on a JST or a XT60, it takes quite a bit. You got to really reel it in. So in this particular case, our positive and negative, positive is near the center like it is with our other parts on the board. Positive here, and negative over here, or ground. I'm going to start with the ground because it's furthest away from me. There, I got it. Again, this is going to be easier if you're not filming. That one went well. Let's do a pull test. Now we need to sort out this VTX and which way things are going to point. Ideally, you'd just do it this way and we'd run this right up through the SMA connector. But it doesn't fit. And I haven't drilled it out yet. Boy, it's so close. Okay, I drilled that out, and it took hardly anything to get that to where it now fits. So I don't know if we're just too tight on our tolerances for design, or if that was possibly I've got a little burr there. If that was something with Armattan, yeah, I don't know, and we won't know for a little while. At least we'll get another frame and see if it's the same way. After much fussing, I did finally get it. I had to go sideways with the VTX, and I had to get it coiled up here on the top. There's just not much space in there, and you can see that we can't quite get as much camera angle as we could when it was naked. This is actually, I think, the maximum back here. It's hitting, it's pressing into all their coil wires here. So, we've run out of space in our micro. And these antennas, I just kind of poked them up through the top because I wanted to keep them safe. The antennas are awful short, so there are same size Lemon RX satellites that have much longer antennas, and then we could use these holes, of course, to run zip ties up through here and get the antennas secured up and out of the way. But these will be fine. I've run my FlexRC Frog, I've run kind of like this in a similar manner. And again, this was about having a relatively simple repair, and now that I know how it goes in, it should be fine. It doesn't move around much. It's also compact down in there, and so I'm not worried about anything getting loose. I did put a little dab, if you can see, not dab, but a little piece of my Gorilla Tape right in there to kind of hold this. You can see how it moves, but that tape works pretty well. I'm not too concerned about that actually coming out and getting in a prop or something. And if we need to, we can always increase the amount of tape that's down there to help secure it a little bit more. So let's do our weight. I think we came in at 150 some grams when we started. Oh, props are on wrong again. Okay, I think that's everything. Nearly ready to fly state. We just need to go through our configuration. Make sure we get this all on here. That went up. I wonder if it went up because of the camera a little bit too. So there we go, 164.4. That's our dry weight. You tack on a battery. This is a 480 milliamp MyLipo. I like to fly with those little batteries. 208, still well under the 250, and lighter than our GB130, and a much lower profile. So now we just need to take the props off. We need to calibrate our ESCs, make sure our receiver's set up the way we want, and we can go fly. So let's take these off and we'll get set up to look at clean flight. Or in this case, Betaflight. Okay, we're all set and ready to plug into Betaflight here. See, we got COM9 now, so detected the board. And as previously stated, I did flash this to Betaflight. Let's do version just to show you that. Betaflight 301. Okay, so in our setup, in case you haven't set up a Piko BLX before, now we have to wait for Betaflight and the CLI to recycle itself. In our setup here, we've got the ability to calibrate the accelerometer. Let's press this as flat as we can. And don't typically use the accelerometer, but we'll go ahead and... Alright, that's finished. Good. And in our ports,
If you're using the Spectrum satellite, you need serial RX on UART3 turned on. Here's our configuration. We've got our quad X, we've got one shot 25, and you can of course change that to one of the others depending upon your ESCs that you're using. I'll probably eventually put multi-shot on here. I use motor stop. Let's lower that a bit. Let's go to 1060, and then we've got our values there, and we've got serial RX for our Spectrum 1024 because it is DSM2. Nothing else set up here. I'm going to go ahead and save as it reopens here. PID tuning, this is all stock except for my rates. I like pretty sensitive sticks. I don't use any deadband or anything unless I have to. Let's see what else is there. We can see our movement over, well, when we make our quad move, you can kind of see how fast it goes. And obviously my receiver is working. You can see here I've got throttle and yaw because I'm using the particular radio and controller. I've got TAER 1234 set up, and that's how it works. And then for my switches, let me move my radio into the shot here so you can see it. If you look on the screen, this is aux1. I use this for arming. Then I use this 3-position switch for the different flight modes. And then this one I will use for the beeper. So let's set those up. And I'll stick with the radio here. So we go into modes. We click add range. aux1. That's the arm position that I want. Go ahead and save that. I'll put air mode. I usually put that in the middle position for aux2. So that was there. And then horizon, if I sometimes use that, aux2 again. And move this slider all the way down to the bottom. And then we scroll down even further to our beeper. That is aux3. And we should be able to put it down here. Yeah, and that will trigger the beeper. So you can see here, if I flick this switch, we get arm. If you don't get arm, it's probably because you've got your minimum throttle and your minimum command set higher than their throttle values. And we'll take a look at that real quick. And I've got air mode in the middle position, and then horizon at the bottom. So it triggers those squares in Betaflight to be yellow. In clean flight, they are green. Okay, let's go back into the configuration. So if you don't get arming on yours, you need to check to make sure that your stick movement for your receiver, see how my throttle's at 999. When I press on early release, it comes up a little bit. And so you want your minimum throttle to be actually above that. And if you don't get arming, that's probably because it's of that. So if I move this stick up to say 1180 and I go back to my modes and I try to arm, see how it doesn't arm? But if I go back to my receiver and I move it down, we got 1004, go back to modes, now we get arm. So you have to have your minimum throttle set properly in order for your copter to arm. That's really about it. Let's go ahead and calibrate the ESCs. We go into the motors. We scroll down here a little bit. We click this box to let them know that, yes, we understand that we do not have our props installed. Take the master slider all the way up to the top. Let me put the copter back in view. Get my little USB cable out of the way. Those are our programming tones. Now we slide it down. Okay, we're all done. And our FPV does work. It says RunCam Owl Plus down there. I'm going to have to go into the OSD, take that off. That might bother me a little bit. So we unplug here. Now we need to check to make sure our motors spin the proper direction. Okay, I found that I had wired all the motors wrong, and I should have already noted that in the video. Pretty certain it was motors 2 and 3 that needed to be reversed, but in this case it was not. So let's go ahead and we'll plug our battery in. And we'll make sure they're spinning properly this time around. Turn on my radio just so it doesn't throw a fit. Okay, so if we slide this over and we turn up the master, we should start to see some rotation. Boy, that's nice and smooth, isn't it? They weren't kidding when this talked about Blheli-S being the bee's knees. And I just kind of touch the motors. We want them to spin in here and in here, just as the label on the top of the motors. You don't have to buy clockwise and counterclockwise motors. Some motor manufacturer companies just reverse the threads. The arrows on the top are just about the threading. It's not necessarily that the motor was designed to rotate one way or another. So we're all good there. Let's go ahead and test the beeper. There we go. That'll help it find in a grass, which these little guys, if you've seen my backyard recently, although I did clean it today, full of leaves. Little micro goes down. Woo, it's tough to find. Okay, I think that's good. So we can bring that down. Let's do one other thing. Let's use our keyboard arrows and let's just go up to see where we start to get smooth motor rotation. Get two motors twitching there. Now they're all running. 10:25, they all kind of start to run smooth. So you probably, for your air mode purposes, want to set it 20 or 30 higher than that. But air mode, you want to tinker with that a bit. You know, you want to fly it and use the air mode when you're doing acrobatics to see is it pushing you down or is it letting you to float but still control the copter. Okay, I think that's it for our clean flight setup. We can disconnect everything here. And go fly. I'll see you outside.